So in order to estimate the tangent of an angle on the unit circle, there's a really important identity which we can use, okay? And we can actually say, well, the tan of an angle, call it theta, that's actually the same as the sine of that angle divided by the cosine of that angle. So we know how to estimate both sine and cosine on our unit circle, and therefore if we divide one by the other, we're going to get the estimate for the tangent. Okay, so for example, let's say that we were asked to estimate what the tan of 60 degrees is. Well, by this identity, it says that this is the same as the sine of 60 degrees divided by the cosine of 60 degrees. So if we draw out our 60-degree angle, okay, so it's an angle that looks approximately something like that. If I was to estimate my sine first, I have to come over to my y-axis, and I see that I'm up here at about 0.85, okay, so 0.85 for the sine of 60. And we know to estimate the cosine, we come down here onto the x-axis, and we see that we're at about a half, so 0.5. Now, if I'm dividing by a half, that is the same as multiplying by 2, so 0.85 times 2. Okay, and we would of course end up here with 1.70. Now, if you actually looked up what the tan of 60 degrees was in a calculator, you would see that you actually get 1.73. Okay, so we're not a million miles away with that example. If we do another one now, so what if this time we were asked to maybe estimate what tan of 45 degrees is? Okay, well, we know that this is the same as the sine of 45 degrees divided by the cosine of 45 degrees. Okay, and we can estimate both of those on the unit circle. Okay, we did that in a previous video. So if we want to do that, we're going to come out maybe somewhere around here. Okay, that would be about our 45-degree angle. Now, if I measure my sine, I come across to the y-axis, and I'm at about 0.7 here. And if I measure my cosine, I come down to my x-axis, and I'm also at about 0.7. So we're looking at 0.7 divided by 0.7. And we can see here that anything divided by itself just gives us 1. Okay, so the tan of 45 degrees, our estimate for it is 1. And if you actually look that up in a calculator, again, you would get the same answer. We see that tan of 45 is in fact equal to 1. One more example now before we move on to some angles in the second, third, and fourth quadrant. So what if this time we were asked to work out what maybe the tan of 20 degrees is? Okay, well again, using our identity, we know that this is the sine of 20 degrees divided by the cosine of 20 degrees. Okay, now I can estimate this using my unit circle. So if I want to draw my 20-degree angle, it might be somewhere sort of maybe around like that. So about that angle there is about 20 degrees, okay? Now, if I measure the sine of that angle, again, I'm coming over to my y-axis, and where am I at here? Maybe about 0.33-ish, so 0.33. And the cosine of 20 degrees, I would come down here, and I'm at about 0.95 here maybe. So we'll do something like that. Now, if I simplify that fraction down, look, it's close. It's approximately a third, okay? It's not a million miles away. So we will estimate this as 0.33, the tan of 20 degrees. So that's our estimate for the tan of 20 degrees. Again, it doesn't have to be perfect, okay? As long as you're showing you're working and a little bit of rough thought process, you should be okay. In fact, if you looked up what the tan of 20 degrees was in a calculator, you would actually get 0.36, okay? So again, we're not a million miles away. What we're going to do now is we're going to open our angle up into our second, our third, and our fourth quadrants, and we'll see if we can do those. So what if we were maybe asked to estimate what the tan of 120 degrees was? Okay, well, if we have a look at what that angle is, that's sort of this angle out here, roughly, okay, which comes 60 degrees off of our x-axis on this side. And so the angle of reference for us would be this angle out here in the first quadrant, which is your 60-degree angle. So this is our 60-degree angle, and this is our 120-degree angle. Now, if we have a look at the x and y coordinates, so if we have a look at our x coordinate here, and we've got some y coordinate, okay, what's it going to be over this side? Well, we get the exact same x and y coordinate, except the x coordinate has now become negative, okay, so we end up with negative x and still the same y coordinate. So because our cosine in this case is going to measure negative, our sine still measuring positive, and here our cosine and our sine both measure positive. So we're going to get a negative tangent value out here and a positive tangent value out here, but both of these angles will be of the same magnitude. Okay, so one will be the negative version, one will be the positive version. So the tan of 120 degrees, that is going to be the negative version of what the tan of 60 degrees is. Okay, and so we worked out previously that the tan of 60 degrees was about 1.7, so the answer to this would be negative 1.7. Let's have a look now using that sort of idea to see if we can sort of work out where tangent's going to be positive and where tangent is going to be negative. So this is our first quadrant out here, our second, third, and fourth quadrant. Let's have a look at cosine and sine in this space. So sine, cosine, both of those are positive. So when I do one divided by the other, I end up with a positive number for my tangent. If I have a look at sine and cosine in this space, I see that sine is positive, but cosine, like we just did then, cosine was negative. So when I divide one by the other, I end up with the negative answer for tangent. If I have a look down here, my sine here is negative and my cosine here is also negative. So my tangent is actually going to be positive because when I divide one by the other, negative divided by a negative gives me a positive. And down here, my sine is negative, my cosine is positive, okay, and my tangent would therefore be negative. So there's a good little acronym that we see. We have all of our things are positive in this space. Only the sine is positive in this space. Only the tangent is positive in this space. And only our cosine is positive in this space. So A, S, T, C. And that helps us remember, especially for our tangent, where our tangent is going to be positive and negative. So tangent is positive here, and tangent is negative here and here. And our reference angles for tangent are always going to be those ones in that y-axis. So let's say that we had another example now. So maybe we're asked to work out what maybe the tan of 200 degrees is. Okay, well that angle there is going to be 20 degrees below my 180 degree line. Okay, so this angle in here being about 20 degrees, that would give me my 200 degree angle there. Well, this is very similar to this angle here, okay, which is actually the same. If I go back to my first quadrant, the reference angle is going to be that one there, okay? So everything with symmetry in that y-axis. Now, what do I see? Well, my 200 degree angle down here is in the positive tangent space. T is positive for tangent. Okay, so tangent, my answer will be positive here. And I know that my answer is positive in this quadrant because I have all of my things are positive in this first quadrant. So my tan of 200 degrees will be the exact same as my tan of 20 degrees. Okay, and we worked that out earlier to be about 0.33. So we've looked at how we can estimate tangents, especially in this first quadrant, using this idea here. This tan of theta is the same as the sine of theta divided by the cosine of theta, and how we can reference our angles in the second, third, and fourth quadrant back into our first quadrant through the y-axis symmetry, and we know where tangent is going to be positive and negative, so we can work those out as well.